We're given g of x is equal to x cubed minus 3x squared minus 9x plus 1. We want to find the critical numbers of g. So for that, we'll take the derivative and set it equal to 0. Here I can factor out the 3 or divide both sides by 3. I think dividing is easier. And so we can factor this out and get that x equals 3 and negative 1. These are our critical numbers. To see when the function is increasing or decreasing, we'll plot our critical numbers here and then just find value to the left of negative 1, which is like negative 2, and then 0, and we'll say 4. So I can plug it into the original here, but technically I need a 3 if you want to be precise, because the derivative has a factor of 3. But for solving purposes, I divided by 3. Doesn't matter because the 3 is positive, so I can ignore it. And if you want to save a lot of time, we know that the derivative is a parabola with zeros negative 1 and 3. So the leading term here is positive, so you know it's going to open up something like this. I don't care what happens down here. Like, I don't care about the vertex. Only thing I care about is to the left and right of negative 1, to the left of negative 1, right of 3, it's going to be positive, and between negative 1 and 3 is negative. So if you're not sure how to do this, you'd always just plug it in. If I plug in negative 2, negative times a negative gives me a positive. Plug in 0, negative times a positive is a negative. Plug in 4, positive times a positive is a positive. So increasing, decreasing, increasing. Now for the second derivative, that would just be 6x minus 6 equals 0. So x equals 1. So we'll just plot it x equals 1 here, and then just pick values left and right of it. Say 0 and 2. Plug it in, you get a negative and a positive. So it's concave down and concave up. Okay, so let's answer the questions here. What intervals is it increasing and decreasing? So increasing from negative infinity to negative 1, 3 to infinity. Decreasing everywhere else, in other words, from negative 1 to 3. So when is it concave up? Concave up is 1 to infinity. Concave down is negative infinity to 1. The inflection point is going to be at x equals 1, since that's where the graph changes concavity. So at x equals 1, we get negative 10. Now we want to see what is the maximum and the minimum, or the relative maximum minimum. So the relative maximum is at x equals negative 1. So when I plug in x equals negative 1, I get that my y value is 6. And then for the minimum occurs at x equals 3, which is negative 26. Finally, I want to graph this. So what I'm going to do is combine the first and the second derivative number line to make things easier. So I combine the critical numbers and then this point right here. So to the left of negative 1, it's increasing. Between negative 1 and 3, it's decreasing. After 3, it's increasing. And then to the left of 1, it's concave down. To the right of 1, it's concave up. So now we'll start graphing. So we have negative 1, 1, and 3. So it's concave down and increasing, and it reaches a maximum at negative 1. And by the way, the negative 1 was 6 here. It's going to reach a maximum of 6. And then I should include another point. We're going to include 0. 0 is 1. Okay. So we know it has to go through 0, 1. And 1 is the point of inflection, which we said is negative 10. So let's include that. And then at 3, that was the minimum, which was negative 26. So again, this is not going to be drawn to scale, but yeah. Okay, so we're increasing concave down to negative 1. Negative 1 to 1, we're decreasing in concave down. So we want to go through the 1 here. So the problem here, this graph is going to look a little goofy because it's not drawn to scale. And then at 1, it's going to change concavity, but it's still going to be decreasing. So it's going to be concave up now. And then after 3, it's going to be concave up, but it's going to be increasing. So it looks something like that. So this is my graph of G.